Okay, my friends, Roger once again, and Fermilab and all of the particle accelerator places, what they're doing is they're trying to accelerate particles, smash them into such little bits that they can find the smallest particles that exist. Well, they're starting with gigantic chunks of material, and they cannot accelerate them to the speed of light. So they can accelerate them up to apparently 84% of the speed of light because the particles are so big that passing through the atmosphere, they are obstructed. Well, if you started with light, which is the smallest particle, you're already at the speed of light. And then if you could accelerate that, what would you get? Well, I can show you what you get. Remember now, electron flood theory says that the Fermi is smashing gigantic, huge, thousands and thousands of particles together and then digging through the debris. Rod and I are sending these, which own huge regions, into a restricted zone, a Venturi, and they force into each other's regions, explode like an atomic bomb. The weak force falls away, which I believe now they are going to call that dark matter. These are basically the particles they're looking for, which is a muon neutrino and electron neutrino. The muon neutrino just comes through as one little force. It doesn't explode anybody. It's the weak force in my mind. This is the explosive force. It explodes when it hits a region, and then you shoot out all these electron showers. Now, I believe this is attached to this. When they both come through together, this walks away from this, and I will show you. Okay, we start with the wave coming through, pulse red laser. There's really only a tiny particle in the middle here, and it controls a huge wave around itself as it comes through. Now, then it does this. We got a Venturi right here, which is a restriction to like 2 airplane wings, which forces that to accelerate. Now, we're working with light. Don't forget, this is light. This is not gigantic chunks like CERN and Fermilab is working with. This is already light. Now, I know Einstein says you can't accelerate it, but I'm going to tell you what, if you can't see that accelerating, I don't know what your eyes are doing. And if you can't see that that is obviously a particle, I also don't know what your eyes are doing. And I will show you something else that you will see that shows that these particles separate from each other when they concuss through this Venturi. And these are the particles that we will see just prior to concussion. They are attached, black and white, black and white. That, I believe, is a photon. 2 electrons, one this way and one this way. Back-to-back electrons. Now, when they concuss, the actual weak force separates from the strong force, which is exactly what they're asking for. Now, don't forget, I'm at light. So if we can make this smaller than light, we're way ahead of CERN. And, bada bing, there is the separation right there. We were here, coming in, and the black parts walk right away from the explosive parts, exactly identical to what they ask for. And then the black parts come back in out here. Now, how they could just decided to come back in here, and how come they're all laying around out here, I can't explain that. I have no clue. Now, they may be the dark matter that they're calling for, that it sits around and just is dark and you can't see it, and then it reacts somehow with reactive particles, which are the fermion type particles, and these would be the bosons, the carrier particles. Now, I just assumed that everybody's always attached to everybody else until they concuss, but maybe these are just laying around, because why would they be just laying over here? I don't know. This is all very confusing at this point, but it is, I believe, because we're using light to start with, because we have accelerated, you can obviously see it was accelerated, you can obviously see that the particles have separated, you can obviously see that that is energetic, and these are not, the black ones are not. 100% of what they're asking for. There's nothing that I can even present that they haven't asked for. There's nothing they can ask for that I haven't presented. Zero. So don't forget, that was the light. It's a ball of light, a ball of magnetism, really, and the particle is way in the center, and it got pulled right out of here because it had to accelerate through the Venturi. That's what a Venturi does. All right, so we saw we had acceleration. We saw we had particles, and here are those particles coming out. And each one of these particles is spinning, creating a field around itself, which is like a polar field because it's spinning at a bazillion miles an hour, and it's a magnetic particle. And now that one's spinning backwards. They all came through as red light, and they all came through pretty similar. That one came through backwards, and then it did this. All right, there's another thing we can't explain. That was that antiparticle, which I think it's an antiparticle, and then it concussed and it did this. Whatever going to happen there, je ne sais pas. All right, so here's John Glenn as he is coming through the ionosphere. Now, the ionosphere is a layer of dense electrons and photons. And he is seeing exactly what Rod shows.
Just as at sunrise, there were literally thousands of them. It looked like just a myriad of stars. Over.
Roger. Are they moving on you or floating with you? Over.
Some of them float almost with me. Most of them appear to be moving at about 3 to 5 miles an hour away from me. I'm going just a little faster than they are. Over.
Roger.
Only really unusual thing so far beside ASC.
All right, I'm just going to leave it at that. You can go up and look. He says they are a certain distance apart. I think he said 7 or 8 feet apart, something like that, which is the zone that they control. Stay in your zone, I'll stay in my zone. That's why they stay this distance apart. He said they're small, smaller than a 1/16 of an inch, which is huge. We think they're so small. Well, they're not that small. If you know how to highlight them, which is specifically what is going on. Rod understands this, and he is the guy to talk to. So this is not silly. I am showing precisely, exactly, identical to what they claim to be the strong force and the weak force, which are these minuscule, unseen particles, and maybe dark matter, I don't know. But I'm going to tell you what, they come from light. Light is the smallest particle there is, and that is what is exciting these particles. So think about that. All right, this is the Royal Institute. These are the authorities on particles. This goes back about 6 months ago.
What that means is that there's something wrong with the standard model. We found the crack, finally, in our understanding of particle physics. There's absolutely no way that we can explain this observation with our current understanding. In fact, the only way we think we can explain what's going on is if there are new particles in the universe associated with new physics processes beyond those that we understand, and that these new particles are interfering with the B mesons as they decay and suppressing the decay to muons compared to electrons. Now, if that turns out to be the case, that will truly be momentous. Forget the Higgs. This will be the first sign of physics beyond the standard model, and it's what we've built the LHC to find out.
All right. What they are doing is smashing gigantic particles together and just digging through debris when we are using light, and we are actually seeing light itself divide. Not only are we seeing light divide from its photon state, which is this, right here where they're back-to-back electrons. That's what is an electron. It has a strong force and a weak force attached to it. 2 of them together, or 4 of them, I believe it's 4, make up a photon. When that photon explodes into its brightness, only the white part explodes. The black part is the boson. You're going to see all this in great detail, and it now replaces the nucleus, which it never worked, because there's no such thing as a completely positive nucleus and completely negative electrons. They would snap together. It's never worked. It's just been nonsense. The electron itself is a dipole. It has a strong and a weak force. That's all it is. The weak force is the carrier. It just rolls away when they explode, as you will see. All right, I guess I did show this, but this is the red pulse laser. And then it gets accelerated at the venturi. It gets pulled out, the particle that's inside. And that particle is, let me see, red electron. It's that little particle right there, and then it starts to get glowier, and then it crashes into the venturi and explodes into its dual particle nature. And the green ones are the same thing. Here's the green ones. See, same thing. All that is almost, it's almost like a guitar string. The green is a little tighter than the red, which is a little looser, so it doesn't get quite the twang, and then the blue is a twangy and real fast. Now, that's the particle, zoom, and it came through as you saw. Remember, it was like this. Now it's separating. The black parts roll right away from the white ones. I think I showed this already, but you know, you can never show it too much. And then, of course, these are the Higgs, or electron neutrinos, call them as you will. They come out from the back of the venturi. The lasers here, bip, 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 bip. Each one of those is a ball like this, with a particle in the center. And everybody's got to get out of the way. So you get a bunch of little glowy particles out here. But then it approaches the venturi, and it has to speed up. Just like a carburetor, just like a hose, nozzle on a hose, exact same thing. Then the particle itself literally pulls itself ahead of the wave. So the wave is like a jet fighter. It trails behind it, as we saw, explodes here. The black particles move away. They come back in, way back here. That I can't explain. And I think they're going to call that dark energy. It is dark, it is. It doesn't do anything. It has no impact value whatsoever. It just seems to have to be, or it seems to be attached like that to the particles when they go through the air in photons. And I think they're like that as electrons. The photons are blocks of them. The electrons are just single ones on another. And when they concuss and explode, you get this, the explosive part, which they would call a fermion, explodes, or they would call that electron neutrino. And this is the muon neutrino, which does nothing. It's just a carrier. So that's electron flood theory, and light is quite easily photoed when you know what you're doing, as Rod does.